Okay, good. Let me share the whiteboard. Okay, so the main thing what I am trying to help you here is whenever we have something, we need to have a very good understanding of what is that, as much as possible understanding, like because we cannot say that perfectly we are uh, clearly everything is known to us, but in the way we look at things and we try to either solve the problem or even to understand, like sometime suddenly if we see something, it may look like completely strange, but we should not fill with our mind that it is a completely new thing, I don't know, so I will just avoid that. We should never have that thought process. So everything should be always in a positive attitude. Whatever we see, we need to see that with what we already know, how we can use that knowledge from what we see from there, and from there we can develop anything out of that. Okay.
Okay.
Okay, so that itself will actually make us to, we can, we will develop our confidence in a far better level, like simple things, but we don't really learn that way, or even we don't understand that way, that actually make us to feel not that much confident enough to face lot of things. Okay, so that's why I started with the very basic things, like even the number representation, like when we say that the numbers we started with 1 2 3 like that, and we have totally up to 9, and then after that we want to make uh, a particular way of representing the numbers such that we don't have a kind of new symbols has to be formed later. So after having all these symbols for the up to 9, then the next one they said 10. 10 is a word in English, or in Tamil we say pathu, but we need a symbol for that. So that one is actually the starting one, the unit position, one symbol, and then they said that this now comes as a position in the 10th position, so the unit position has to be put 0, right?
Yes. Yes.
So then we realized even the before the 1 there was a 0. 0 has to be there. Then only things can go like that. Then in cyclic we say that after that is 11, 12 like that. Then even these numbers, like we know that how it goes, and all the numbers and everything, even these things, when we are using this for counting something, we can count like 1 2 3 of something only if they are all of same type, right? If they are all apples, we count 1 apple, 2 apple, 3 apple, that we need to be clear with. And also when we are looking into the counting, let's say we have 5 apples, then we know that straight away we can say 5 apples. But by the look of it, we don't need to, like when we say this is apple, 1 apple, 2 apple, 3 apple, 4 apple, 5 apple, totally 5 apples, even though we count, but eventually this 5 is formed with adding 1 plus 1 plus 1 plus 1 plus 1, right?
Yes. Yes.
So already when we are counting itself, we started doing this addition process. So that itself is telling us, if you are going to count 1 2 3 like that for the same type of item or the measure or the units or something, then the addition should also follow the same rule. One can be added with another one only if all the ones belong to the same type, right?
Yes.
Then also we started using the number line system, like 0 of a particular quantity, then 1 2 3 4 5. So 1 2 3 4 5, for example, this, if this number line is representing a particular type, it could be apples itself, right? Then only we can say that 1 2 3 4 5 are all of apples. If no apples is there, then it is a 0 apple. That is our reference. Okay.
Yes.
This understanding has to be very clear, like back of our hand. These things should be immediately understood. And also we realized that the direction is also important in the numbers. This direction we call that as a positive direction, right?
Yes. Yes.
and we have a unary operator plus as the symbol. So when we say 5, actually a 5 is in front of that. Sorry, the plus symbol is in front of that, but we don't normally write it. So actually, if we write 5 apples, actually this means
Plus.
yeah, this means plus 5 apples. Okay, that is very important. So this actual meaning is plus 5 apples. We should never forget that. Also, once we have a direction in the number line or counting in the increasing, so the positive direction is also increasing, is counting in the incremental counting, right? Incremental counting. Then we know that the opposite direction is the decremental counting, right? So this could be in this direction, right? Opposite direction is the decremental counting, that we call that as the negative direction and direction. And once we cross the 0 point, we still have numbers to count, decremental counting. These numbers we have to differentiate from the positive numbers, that is the plus numbers. We need to use the minus symbol. That also, a representation humans agreed to use for that, right? So we should not get confused with all of these signs. Everything got their own meaning, and what is universally accepted by the humans, and then how this has to be used when we are using it in our calculation or for doing some mathematical modeling or something like that. Automatically these things will come into picture. Do you get that?
Yes.
Okay, so slowly, one by one, the humans, for the requirement, they started, okay, definitely counting was very important, because that was needed. Like even when they were even Stone Age or even before that, if they want to say that, okay, I got today I went for hunting and I got 2 deers, they have to say 2. So the counting started very, very long back, and they used a lot of symbols for that. Eventually this came into existence under the number system, and even in the number system, even though we said counting and addition, and then the decremental counting, this addition, we have the subtraction. Let's say 5 apples, and we take away 2 of them to eat or give it to somebody, 2 apples, then it becomes 3 apples, right?
3 apples, yes.
Yeah. So this is simply like plus 3 minus, plus 5 minus 2, right?
Yes.
So if you put it in a number line, simply from the 0, plus 5 is 1, 2, 3, 4, 5. So this is our 1, 2, 3, 4, 5, all plus numbers, right? Positive numbers. Then this actually made us from 0, we went all the way here. Then this minus 2, so the plus direction actually told us to go in this direction. This minus is actually telling us from where you are currently, that is 5, you go back opposite direction, that of the plus direction. How much amount of the 2, then we go to the 3, that is our plus 3. So that is what this answer is. Do you see that?
Yes.
That should be very clear. It's not that the symbol, the sign in front of a number is an unary operator, and that is meant to explain us in what direction that number is. Okay. So if this understanding very clear for us, we will see that slowly that is not only the horizontal number line. We have the full space, right? So this could be horizontal number line, and this could be the, so is in this direction we have the other quantity humans have agreed, and we learned we need an angle, right?
Yes.
So this particular, we all agreed, let's start the positive horizontal axis or x-axis. Normally we use the x for the horizontal. So positive x-axis from the origin 0, we call this as a 0 degree or 0 radian, right? Do you learn what is the radian unit for the angle?
Yes.
Okay, we will cover that in detail, but we need to know that this is 0 degree and 0 radian. And then when we complete it, then it become a completely, we finished 360 degrees. So we start with a 0 degree and we end with a 360 degrees. Okay. So this one was probably it all might have started with something which was periodic evolution. Evolution is something like whichever is dynamical. Okay, dynamical. So for example, our day night, right? The day night, and then again day night. It is periodical. Do you see that?
Yes.
Okay, so this was actually helped us to form the time. So the time is always the time is one of the time and the space are the two important the variables or the entities or quantities apart from the items and the things and the species on the nature. We know that time elapse or evolve, and also when we see the space, we see the space also. So we need to understand the time and the space, but the time is actually understood as a one-dimensional quantity. You know what is a dimension, right?
Yes.
One-dimension quantity. And also, I mean, as long as it is a quantity, we can count it, and it is continuous. That is another important property we need to adhere to that. Continuous. Okay. What is continuous mean? Let's say we represent the time in the number line. So this 0 and this axis is our time. Okay, time t, and the time t is the t, lowercase t is the variable we use for the time, because in mathematics we need a single. So the uppercase, the first letter is used as the variable name, time t. And also, I mean, I have mentioned this earlier, lowercase letters are used for varying quantity. Okay, varying quantity.
Okay. Yes.
So that means the t, let's say we use the axis name as t, then it could be 0 time, or it could be 1 second, for example, 2 seconds or 3 seconds, like that, right?
Yes. Yes.
Okay, so what is the meaning of when we use the time as the axis and the seconds as the unit, and we put a number as a 0, 1, 2, 3? Obviously there are negative numbers like -1, -2, -3. What they are actual meaning, use the same thing like the direction. The 0 is actually our present time. Do you get that?
Yes. Yes.
Present time, and all the positive times are our future. And opposite direction, in this direction we had our past. You see that?
Yes. Yes.
So always the reference is very important. So with the reference only we can quantify anything. So with the reference we will have the direction, and then the how much quantity in that particular direction. That will quantify a given type of the quantity. So time itself also will have a reference point. Otherwise time is continuous. It is always evolving, elapsing, and it is all happening. Nobody knows when the time started and when the time will end. It is all happening. But for quantifying something, let's say we are doing some experiment, or if you want to tell to somebody, like we want to have an appointment, like on a Sunday, for my time 10:30, and for you is actually what, 10 plus yeah, that is actually 15 hours, right? We started at 15 hours. So that is a reference. So you can see that when the humans were trying to quantify the time, it took long time for them. It's really because they could not understand how this can be done. Like because it's periodically changing, the day night. Then it has to be a cyclic. So it has a cycle. So the cycle they understood through the wheel symbol. So the wheel is the rotation, like a circle. So they realized that the circle is an important shape. Like they understood number line can be in a straight line, but the time is always represented in a cycle, because after that time, though, so they had a reference. For example, this 12 is the reference. Then once they complete this whole thing, they have to come back to the 12 because again the things is starting. So they split the whole day into 24 hours. Periodically, it is going to happen again and again. And in the 24 hours, they used the 0 to 12 for the first 12, and then the next 12 to 24. That is again it is going to 0 for the second thing. So in a clock cycle, they used 2 revolution or 2 rotation of the 12-hour clock for our 24 hours. Do you get that?
Yes, sir.
So, as I said, the time is continuous. That means if there is a 0 and 1, it doesn't mean that you can count only 0 to 1. Even within that, we can say that okay, this is half a second. Do you see that?
Yes, sir.
Right? And even with this half, we can still say that okay, this one is here 1/4. So like that, you can go. So even if you go any minutes from 0 to next value, you can have, as small as possible. So you cannot say that it is increasing in a stepwise. So those kind of variables, we call that they are all continuous. Okay, continuous. That should be an understanding. Continuous variable. That means it can take all the variables, all the values from one to the next. There is nothing called a step value, no missing value in between. But there are a lot of other data or quantity which can be discrete also. We call that as a discrete variables. Yeah, variables that even though we cut an apple or something like that, but normally the apple will available as a 1 apple, 2 apple, 3 apple. Do you see that?
Yes.
Naturally, you cannot ask a tree to grow only half an apple. That is not possible. It will grow only a 1 apple. So that is the kind of, so it all representing a kind of quantity we know and what to do with that. That will tell us how to represent them and how to make use of that. So when we come to the clock, okay, we have this, and they even from the clock, the cycle clock or looking like a wheel, they even made the angle also out of that. Okay.
Okay.
So how the angle is, they even the clock was separated like a single cycle or a round, or the wheel is a 12-hour, and they split the 12-hour each of them like this is our 3 and this is our 6 and this is our 9, and within this 12 they actually split them into, so 1 hour is split into 60 seconds, right?
Yes.
60 minutes. Okay, minutes. 60 minutes. So the minutes actually also helped us, and then the 1 minute is actually split into 60 seconds also.
Yes.
So to use the angle, actually they used instead of they used the 60 minutes and 60 seconds, they split that 60 into 60 or 6 times 60. So they used the 360 as the cyclic in terms of degree. So they just used from the origin. Say they agreed that this angle is a 0 degree. Okay. And they completed 1 cycle, then they said this is a 360 degree. And also they used the opposite. We agreed that this direction, that is anti-clockwise direction. Okay. Anti-clockwise direction. Again, you see the direction comes into picture. Anti-clockwise direction is the positive angle direction. Okay.
Okay.
So the meaning is when we go like exactly to the vertical line, this from here we say that this angle is positive 90 degree. Okay. Yes. It has to be in this direction. But if we have gone in the opposite direction, for example here to here, then we say that this is negative 90 degree.
Negative 90, yes.
Yeah. So like if you go from the 0 linear axis, this is our positive quantity direction, and in this direction is our negative. So that is the same thing we do for cyclic thing also. Okay. So this has to have a good understanding. Also, when we can reach this minus 90 directly from the positive x-axis in the clockwise direction 90 degree, this is okay. And this could also be achieved by going like this, right?
Yes.
Okay, so if you have gone like this, this could be like directly 270 degrees.
Yes.
So that is actually, so we can easily write minus 90 degree is also exactly equal to 270 degree, because the 360 is the cyclic, because we know that the 360 minus 90 degree is only 270.
Yes.
So a positive 270 degree is nothing but our negative 90 degree. Okay, so here itself we could equate a positive quantity with a negative quantity is actually telling us we need a lot of understanding here. This cannot happen with numbers. Only with the angle this can happen. Do you see that?
Yes. Yes.
So cyclically they can have the same thing. So that is a separately a different understanding, and this should not give us any confusion. And also one historical information, you know, the ancient Babylonian civilization.
I've heard of it.
Yeah, they had a number system which was based on 60.
Okay.
Not 10, like humans now agreed that we have 10 fingers and mostly we use the decimal number system. But the Babylonian, they used the 60. That might be the reason why the minutes are divided into, the hours are divided into 60 minutes, and 1 minute is divided into 60 seconds.
Okay.
And 360 is used as an angle, all based on their civilization. Also, we discuss about that. Yeah, 1 degree could be sometime a huge unit for some cases. So we equate that to 60 minutes. Angle also got a minute, right? And this is represented as 60, a single apostrophe. Okay.
Okay.
And also 1 minute is actually equal to 60 seconds in angle. Okay, this is written as 60 seconds is double apostrophe. Okay.
Okay.
So if I write like, you should understand what is this. So this is the quantity of 7 is an angle with 7 degree, 36 minutes and 15 seconds. Do you see that?
Yes, uncle.
Okay, so what it is, so if you use the axis, so this is our 0 degree, 0 minutes, 0 seconds. Now we are talking about, let's move to go in the anti-clockwise direction, so that, okay, so this is actually going to be that whatever the 7 degree. So if you split this whole cycle into 360 equal pieces, this will be, so totally it starts with 0 degree here, it ends with 360, right? So
Yes.
if you split into equally 36 equal pieces, this will be 1, 2, 3, 4, 5, 6, 7. And from 7 to, there is a 8 here. This is the 7 degree and this is the 8 degree. Do you get that? And between the 7 and 8, so this is, there is a cycle part. This is a 7 degree part and 8 degree part. Do you get that?
Yes, sir.
So this 1 degree gap between the 7 degree to 8 degree can be split into 60 equal pieces, and if you take one small piece, that will be 7 degree 1 minute. You get that?
Yes.
Because 1 degree is equal to 60 minutes. And also if you take one that is 1/60th of a degree will be 1 minute, and if you take that 1 minute to small arc portion angle, split that into 60 equal pieces, if you take 1 out of that, that will be a 1 second.
Okay.
Okay, so that we need to understand. So simply these are all telling us how to understand the number system also and the actual meaning. So if you take any quantity 0, 1, 2 like that, these are all, gap is from 0 to 1 is a 1, and in this direction it is actually positive 1. From here to here is actually another positive 1. So if you want to jump directly from here to here, we say +1 + 1, which is equal to +2 in this direction, right?
Yes.
Right? But whole numbers are understood. Even the opposite direction is understood. Let's say we jump one step in this direction. In this direction is a negative direction, so we would have gone to a -1. So this is a -1 jump, right? But some quantity need not to be one jump. So from the 0, we may need to take only half a jump in this direction. So now we need a representation for this quantity. So this quantity is not a one whole quantity, it's a fractional quantity, right?
Yes.
So when the fractional quantity comes into picture, we need to have a way of representing that, and it should be global also. Like we should use that to understand, and it should not confuse us. So how this, first of all, the whole numbers are all found. We say this is a 1. Actually, this is a 1 out of a 1. 1 out of 1. This is a 2 out of a 1. Do you get that?
Yes, sir.
What I mean is, if you formed a 1, like from 0 to 1, we say we have made a 1. But this 1 is made from this quantity, the 1 jump. Do you get that? Positive 1.
Yes. Yes.
So this is a one quantity which is represented from the one whole quantity. This is 1 of 1, meaning if this is a, let's say this is an apple, then we say 1 out of 1 apple. That is the meaning here.
Okay. Yes.
Yeah, 2 whole number means it's actually 2 by 1. This is always there. We cannot avoid that. Because we have to say that from where this source comes from. We want to say 2 made of what? Ones. 2 ones is actually there. So we need to write that in the denominator. That is always there.
Okay.
Okay. So if that is what made the how to write the fractional quantity also. Let's say we take a 1 full quantity and we split into 2 equal pieces, piece number 1 and piece number 2, and we take only 1 out of that. That is why we jump only half the way through. You get that?
Yes.
So to represent that, we use this one is actually, we say that how many equal pieces we have made of a 1 whole quantity, and out of that, so from a 1 whole quantity, we actually made 2 equal pieces, and out of that we take one amount.
Okay.
You see how the half is formed?
Yes.
Yeah, 1 is, or you can think like that. Yeah, 1 is divided into 2 equal pieces. Out of that I take only 1. This become our half. Okay. So if you say that, okay, yeah, 1 is divided into 2 pieces, but I take 2 of them, then this is actually our 1, because we divided into 2 and we took this whole amount. Both the amount. Do you see that?
Yes.
This is the reason why they say that graphically this is very simple. So from the 0 to 1, we split into 2 equal pieces, piece number 1 and piece number 2, and we take both the pieces. We take this piece, add with this piece. So this is an half, this is an half. Either we can say that this is a half plus half, which is actually our 1 we started with, or it could be a 2 multiplied by half. That is also 1.
Okay. Yes.
You see how the repeated addition also coming into picture as a multiplication.
Yes. Yes.
And this is the reason also, like when we do the deal with the fractional quantities, we say simply, okay, how to add numbers. Like, okay, 2 plus 3, we say that 5. And with our in-depth understanding, we know that 2 should be of the same type of the 3. Then only it can be added, simplified to become a 5, right?
Yes.
But let's say I want to add a half with a half. Then I look into it. What is this? It is not a whole number like a 2 and a 3, because 2 and a 3 straightforwardly we say, like example, 2 apples plus 3 apples. But this is the number representation itself is a half plus half. let alone what is the quantity. It could be half apple and half apple, but we need to understand this representation very clearly. Then only it will help us how to add with a similar type of representation. Do you see that?
Yes.
So what is this half? Okay, it is very clear. A number system, like, it could be a 0, and we have, like, okay, let's say the representation of the number itself. This is a 1, and this is a 2, and this is a 3. This is whole number representation is okay, but nobody told us a number line should be split into a one full portion, right? This is a +1, +1, +1. This is just for requirement. Like when we want only whole numbers to be treated, the number line become like that. But this whole thing could be like from 0, it could be a count of 1, 2, 3, right? This could be a count of only half each, right? Nobody stopped us.
Yes. Yeah.
Right? Then we say that 1 out of what? That is what we have to say. You see that?
Yes.
This become a different numbers actually. The look of it itself so first thing is the reference is very important. Second thing is how much is one amount is represented with. That is very important.
Yes.
So this is the we call that as the unit quantity.
Okay.
Okay. So the unit quantity, even though it sounds like unit should be a 1 or something, actually it is telling what is this one smallest piece we are talking about. That we can understand like that.
Okay.
This quantity is needed that can be used for representing all the rest of that quantity in the positive direction or in the negative direction. Do you get that?
Yes.
Okay. So here also, as we jump 1, 1, 1, these are all 1 over 1. That is why I said this is very natural. Representation of divided by 1 is very natural. Right? And also the multiplication also comes into picture. Let's say I want to make, how many jumps I make? 1, 2, 3, 4 for the number 4. That means I made 4 same job of adding 1 multiplied 4 times. That is what 4 is. So this comes from 1 plus 1 plus 1 plus 1 is 4. So repeatedly we are adding the same type. How many? 4 times. So this 4 times is to be used as the first number, and what quantity is repeatedly added should appear here, and the process is mathematical operation is called a multiplication. The symbol looks like that, and we can multiply 4 with a 1 straight away, as they are both are made of unit quantity. Do you see that as a one quantity? 4 is also is a whole number, and 1 is also whole number. That's why we come out with a whole number as an answer, right? Okay. So now that's the same thing. Like when we say that in the number line, if the jumps are all half, they are all of same type, right?
Yes, they are all of same.
So, yeah. So when we say half plus half, no problem, because we see that how a quantity is divided into 2 equal pieces. This quantity also, this also divided into 2 equal pieces. Then adding the numerator is not at all a problem, because as long as they belong to the same family, how much we divided into, that is telling us that these are all of the same type. Do you get that?
Okay, yes.
So that makes it's actually the family of 2, and these are all goes 1 to together, and 2 by 2 equal to 1. 1 to 1 it goes like that.
Okay.
You see the understanding? So
yes.
when we go for like the half plus 1/3, now comes the problem. This family belongs to dividing by 2, this family belongs to dividing by 3. So it belongs to 2 different family. So this half, let's say we represented that as 1 jump, 2 jump. So this is our 0 and 1, but this is our half jump. Do you get that? This is another half. So this is our half quantity here, sitting here. But the 1/3 is actually the same 0 to 1. But what we have done, this is our 1. We have divided this into 3 equal pieces. So this is our 1/3, another 1/3 and 1/3. So 1/3, 1/3 and 1/3. Our 1/3 is sitting here. This is our 1/3. Do you get that?
Yes. Yes. Yes.
So if you see both of them, they belong to different things. So we have been asked to add this 1/3 with this 1/2.
Yes.
That is not good at all, right? So what we need to do, let's say we need to check that if this is sitting here and this is sitting here, can we know that one length is like this, that half is like this, and 1/3 is like this. Can we bring them to a common family? That's the question we are asking. Okay, that is possible. What we could have done, if this is split into 6 equal pieces, like and this also split into this also split into 6 equal pieces, like this is split into the half up to here is split into 6 equal pieces. Do you see that?
Yes.
Okay, that is actually
Let's see how we take the LCM.
yeah, this will be 4th. So 1, 2, 3, and this is 1, 2, 3, 4. So this will be 1/3, right? 1/3, and so totally we need, this should be totally 6. 1, 2, 3, 4, 6 should be there. Okay, 4, 5, 6.
Okay.
So out of the, so that is what we are making. So this is, so this one we are saying each piece is 1/6. You get that?
Yes. Yeah.
This is 1/6. This is 1/6. So if you have divided like that, to get a half, we need 3 of them.
Yes.
Okay, so that is half can be also written as 3/6.
Yes, it can be written.
Because if half is split into like 1/6 plus 1/6 plus 1/6, that is same as our 1/2, right? And similarly, the 1/3 can be written as 1/6 plus 1/6.
Yes, sir.
Okay, do you see that?
Yes.
Then you see now this whole half, now it is written as 1/6 plus 1/6 plus 1/6, and this is our family of the half split into, this plus symbol remains, this 1/3 become 1/6 plus 1/6. You see that? So totally we are talking about 5 of that. So 5/6 is actually the answer for this 1/3 added with 1/2.
Yes, sir.
Okay, so that is what, I mean, always this is what we are doing in mathematics. Either way, when we go from small understanding to a bigger understanding, or straight away trying to work out what is the bigger thing. So that is what we have been told. If this is actually adding with this, we asked, okay, denominator check whether, as long as this is a plus or a minus. Addition or subtraction have this trouble. I will tell you what happens to the multiplication and division. Okay, they are much simpler operation than addition or subtraction. Take me, this is actually natural. Multiplication and division is a much natural mathematical operation compared to the addition and subtraction. Okay, this is complicated. Actually, this is complicated, and this is simple. I will explain you why. Okay.
Okay. Is it because the basis needed these?
Yeah, this needs a condition. This needs a condition. This tells that we need of the same type.
Yes, but multiplication and division is not.
Yeah, because I will tell you also. I mean, this needs understanding why the multiplication and division need not to care about to which with what we are doing something. As long as they are operating alone, you take a 5, multiply with I mean whatever it is. You can even ask, I mean 5 apples, multiply with 5 apples. Well and good, we can do that. You will say 25 apples square. Naturally, it may look like a meaningless, but mathematically this is perfectly correct. This is possible. We will be using for some analysis kind of thing. We will come to that later. I mean, already you have done that, right? You have done some bit of probability, right?
Yes.
But you have not done up to the distribution, right? Normal distribution or standard deviation. Have you learned variance, standard deviation?
No.
Not yet. Okay, so that will come.
Very simple. We just had cards.
Yeah, the basic probability. From the probability, you will go a little bit towards the what is here average, and then the mean, and then the variance, and then you go to the standard deviation. That will be coming later in this year itself. You will learn all of this. And next year you will learn the distribution also. In there, you will see that there is a quantity coming out like apple square. Even though this is not natural, it will come as apple square. Then the math will take care of it later. But what I am trying to say here is multiplication and addition are simple one. We will understand that. But why this becomes complicated? Because this is constrained, right? Because only of the same type. So now we have a trouble. This half is actually made from the quantity split into two equal pieces, but 1/3 come from a quantity split into three equal pieces. So the addition or the subtraction, if this has to be performed between these fractional quantity, we need to make them of the same type, like the same units. Like when we have 1 meter add with 20 centimeter. Here also, even though they are whole number, we have trouble because the units belong to the two. They are telling us bring them together. So we say that this is 100 centimeter, then add with the 20 centimeter, our problem could be solved. You get that? This could be a 120 centimeter is okay, or 1 second, or we could take this, keep the 1 meter, this 20 centimeter can be written as a 0.2 meter also. Yeah, so that will make it as a 1.2 meter. This indirectly tells us 1.2 meter is nothing but in a representation 120 centimeter also. You see how much understanding is going on here with the units and the fractional units, numbers, fractional numbers, the representation. This can be written as 1.2 meter is same as 1 2 by 10. Meter is also same.
Yes.
You see that? So because 1.2 can also be written as 12 by 10.
Yeah, it is 1 plus. Yes.
So yeah, 1.2 is also written as 1 plus 0.2, and this 1 will stay as this. 0.2 can be written as 2 by 10, and there is a mixed number representation also that can be written as 1 2 by 10.
Yes.
And mixed representation can be made as an improper fraction also, that is 12 by 10. And this can be divided also as a decimal. It can be written as a straightly you can divide and say 1.2, or you can simplify that as 12 by 10 can be simplified as 2 by 5, and the numerator is 2 by 6. Then 2 to go 1 to 1, and this is 6 by 5. So all these things are all because of certain process. Do you see that?
Yes.
And so to do the addition or subtraction, come to here, we are making that one easy way is one method is find the least common multiple between the 2 and 3. That can be done between 2 and 3. One is a even number, another is a odd number. Most likely this is the best stupid least common multiple. This is 2 multiplied by 3, and this is 3 multiplied by 2. So here the denominator had only 2 and the numerator had only 1. We have done something extra with the multiplication with 3.
Do it on top also.
Yeah, that will actually keep the value of the half same. So this whole value is exactly same as this value. That is what we need to take care of. That will avoid our silly mistake. So whenever you do a next step, try to go back a step by doing the opposite operation. Can we cancel this 3 with 3 1 to 1, and this whole thing can be simplified to see that this is nothing but my half. Do you see that?
Okay.
So add with the same thing. We are saying 3 multiplied by 2. 3 was the only thing earlier, 1 was the only thing earlier in the numerator. Then extra operation is multiplication by 2 on both the numerator and denominator. So this can be naturally divided 1 to 1. So that still 1/3 is maintained here. Okay. Yes. So here we have come to a point that now we come to a question. Plus 1/3. Actually we have written this as a 1 multiplied by 3 divided by 2 multiplied by 3. Add with 1 multiplied by 2, 3 multiplied by 2. Here is actually mean take only this guy. Okay, this guy is what 1 multiplied 1 by 2 multiplied by 3 by 3 actually.
Yes.
Okay, so this 3 by 3, once you simplify that, it looks like 3 can go with the 3 numerator denominator 1 1. This is actually a 1.
Yeah.
Okay, but we have started with addition of two fractional quantities, right?
Yes. Yes.
That naturally made one number is made into a multiplication of, only that half has become a multiplication of two fractional quantities here. Even though 3 by 3 is a 1 after simplification, but the current form 3 over 3 is a fraction. Do you see the fractional form?
Yes. Yes.
Okay. So now what is actually doing? What is the meaning? Multiplication is a repeated addition, right?
Yes. Repeated.
Repeated addition. So that itself, already when we say that multiply off with a 3 by 3, we are just saying like, okay, can you add 3 by 3 only half a time? That is what we are asking.
Yes.
Because if you say 2 multiplied by 3, we are asking can we do the addition of 3 2 times itself. This is actually 3 plus 3. So we are, when we say half multiplied by 3 by 3, we are asking can you take this quantity 3 over 3 and add 3 over 3 itself only half a time. That is this multiplication means.
Yes. Yes.
This is, I hope this is not confusing.
No, it's not confused.
Yeah, if you say 2 multiplied by 3 over 3, this we know that 3 over 3 is the one getting multiplied twice. So write 3 over 3, add with 3 over 3. So totally 2 times.
Yes.
That is what it is. So now we are questioning simply half multiplied by 3 over 3. So if you write it as a 3 over 3 itself, already this is multiplied by once, right?
Yes. Yeah.
This is not good at all, because what I mean is this is already overdone. Do you get that? But we need to add it only. This is already added one time to. That is what the 3 by 3 is. We want only half of it. Do you see that? Yes. So this whole thing has to be only if you do that this will happen.
Yes.
Because if you say 1 multiplied by 3 by 3, this is the one whole quantity of this 3 by 3. Only one time.
Yes.
2 multiplied by 3 by 3, okay, good. This is 3 by 3 plus 3 by 3.
Plus 3 by 3, yes.
But we are asking half multiplied by 3 by 3. This can be understood. One possibility is if you want to do it by the addition wise, half is actually a fraction. It's not a one whole number.
Yes, it's a fraction.
Yeah. So we can also understand that when it become a fraction, it can be also understood like, okay, like if it is a scale of this is 0 and this is 3 by 3 number, then this is another, this is 2 times 3 by 3. Do you get that?
Yes.
Then we can straight away 3 by 1 times 3 by 3, we will go here. 2 times 3 by 3, this is actually we will go here, straight away from here to here.
Yeah.
You get that? But half a time 3 by 3, we are asking not even going one time, we are asking going only half of it.
Yes. Yes.
Okay, that means if you multiply by 1, you go here. But we are asking halfway come back. So this direction is a subtraction. Do you get that? This direction is a negative direction. Opposite operation. That is what mathematics is all about, understanding that. So also we can say that now look at here, number line also is helping 0, and this is our, for example, is this our 3 by 3. We are asking, we go only halfway through. So if you are already here, can you go back halfway here? So that means if you know what is this quantity, we can take the 3 by 3, take away this quantity, right?
Yes.
Okay, because this is 3 by 3 by 2. This is also another 3 by 3 by 2. So take the 3 by 3, subtract it by 3 by 3 by 2. That is what the meaning of half times 3 by 3.
Okay.
Okay, I hope this is not confusing. I hope,
Yes.
right? Yeah. So now again, this is a 3 by 3 quantity. This is a 3 by 3 and half of that. So they are not, subtraction is actually stopping us. So even though multiplication could have been done straight away, but the subtraction, what this is actually asking us, can you make this also belongs to the same family of this?
Yes. Yeah.
Right? But that comes with the number line system also. We know that this is nothing but made of 2 of this quantity, right? This plus this is our, so this can be split into 3 by 3 by 2 plus another 3 by 3 by 2, take away 3 by 3 by 2. Do you see that beauty?
Yes. Yeah.
Okay, we should be very, like, I would say that, let's say we are at a one point, we will be vigilant not only the 360 degrees, but also you see, you put a spear, like, do you see what I'm saying?
Yeah.
Like we will be vigilant, like not only the around us 360 degree, even above, below, everything. Like,
Yes.
can we have the full deepest understanding of all of these, even the very basic stuff, without any doubt, our confidence level will be good to deal with any of this. Okay.
Okay.
So that actually makes us, you can expand this, that is 3 over 3 by 2 plus 3 over 3 by 2 minus 3 over 3 by 2. So these two guys is actually made us to jump straight away. Do you see that?
Yes.
And this final guy is saying go back 1 half.
Yeah.
So this number is actually, so instead of going 2 jump and come back 1 jump, it is enough to go 1 jump. One jump is nothing but your 3 by 3 by 2.
By 2. Yes.
Okay. So you see, this is a repeated addition of the same quantity 2 times.
Yes.
Okay. So this is actually 2 times 3 by 3 over 2. That is what our 3 by 3 is.
Yes.
Okay. But that makes the multiplication is the simplest process than the addition. If you say 2 times anything like 3, already this 3 has to be added by itself 2 times. That is what this meaning. But we already said that the 3 is only one quantity, right? Then this 3 also will be the same quantity. That's why this becomes the same quantity of this. So addition is straight away easy.
Yes.
If you are given straight away 3 plus 3, we will ask you a question, what is this 3 and what is this 3? Do you see that?
Yeah.
If this 3 is a meter and this 3 is a centimeter, then we are in trouble. We cannot add 3 with a 3. We need to do some job to convert meter to centimeter or centimeter to meter and get the job done. Do you see that?
Yes.
But in this 2 times 3, this is already taken care. This 3 of whatever this quantity, it could be only meter or a centimeter. You could not have both the meter and centimeter for the 3. Do you see that?
Yes.
Then this number 2 is actually telling this 3 has to be repeatedly added by itself. So let's say this 3 is a meter, then actually we are asking 3 meter add with 3 meter 2 times.
Yes.
Automatically. So that's why the addition or subtraction needs a constraint that the quantity are of the same type. But when you say represented already in the multiplication, that means we checked what quantity is repeatedly multiplied, that is of the same type, that is the number of times the 2 has come.
Yes.
This is the reason when you are given as a 1 by 3 multiplied by 1 over 2, we don't care about the LCM or something, because we are saying, can you repeatedly multiply, add off only 1/3? Do you see that? That is the meaning of this whole thing.
Yes. Yes.
Do you catch that?
Yeah.
1 times off is 1 full, so this will be a 1 full thing. But we are not asking 1 times, we are asking only 1/3 of that. Do you see that? So this means this half, 1/3 of that only we are asking for. So this one we simply say as long as multiplication, multiply numerator with the numerator. This is blindly learning, but this is the reason why this comes as a half over 3. A 1/3 of the half. That means you take a 1 to half in a number scale, and can you split into 3 equal pieces and take only 1 out of that? Do you get that?
Yes.
So this is half by 3. This is half by 3. This is another half by 3.
Yes.
Okay, so this half by 3 is nothing but 1/6.
Yes, sir.
Okay, so that is why sometimes they say blindly multiply these two quantity. You get that 1/6.
Yeah.
But we need to be careful in what is dividing or what is multiplying with what. Okay, so let's say if you say like 2/3 whole thing divided by 5/6, for example. Okay, here the understanding has to be, first of all, this line, this divisional line is actually making this whole thing is the numerator for this division. Do you see that?
Yeah.
This
And
is the
then
denominator.
that's 5 by 6.
Yeah, that is what we need to. But this numerator itself is made up of further a division, and there is a numerator denominator for that. And so a number like that, I mean, even though it looks so complicated, we don't like the 3 sitting here. Do you see that?
Yes.
We don't like the 6 sitting here.
Yes.
So how to get rid of the 3? First of all, okay, if I can multiply with a 3 here, that will get my job done, right? The 3 will go with a 3.
Yeah.
But I disturb the fraction, so multiply this also with a 3. That will help me. Yeah, this goes with 1 to 1. So the numerator will simply become a 2 divided by, here this also, between this we can go 1 to 2, right?
2.
This will be 5/2. Still is a problem. We simplified this 3 problem. Now the 2 is a problem. That can be solved by multiplying by a 2, balanced by doing a 2 here.
Yes.
So this will go 1 to 1. So this will simplify as a 4/5.
4/5. Yes.
Okay. This is also, so the 2/3 whole thing divided by 5/6. People simply say take the numerator fraction, multiply with reciprocal of.
Yes.
Yeah.
This is
Why the reciprocal is happening? Actually, this is the reason. First, we get rid of this fractional thing like this and this fractional thing 1 by 1. That is what making us to do this reciprocal. That will also give you the same 1 to 2. This will be 4/5. So we need to, that's what I'm saying. We need to be vigilant on all direction of what is going on. Then our handling will be very easy. The representation is very easy. You have time, right? Or you are busy right now?
No.
So, because I want to extend this idea and everything as a generic one. Like let's say we have 1/2 divided by 3. Right? So obviously we are asking half has to be divided by 3. We know that it will be 1/6. Do you get that? We should have the feel of what is going on. This is a feel. Like half has to be divided by 3. Already half is a fraction. If you further divide that by a whole number, it will only become a further smaller number than the half. You get that?
Yes.
Yeah. But straight away, if you want to handle this can be written as half divided by 3. We don't like the 2. Multiply by the 2. Here also 2. This will help us 1 to 1.
1/6.
So 1/6. Either way, we should be ready to deal with that, right?
Yes.
Okay. Same thing. Like let's say there is a 3 divided by half, for example. This tells us 3 is a one big whole number. We are asking divide that by half. Do you see that?
Yeah. Divide by half.
Divide by half. That means it will go bigger than this 3.
Yes.
Do you get that?
Yes.
So how much time? Like actually 2 times. That is what this is. Because this 3 is divided by only this 1. This divided by 2 will actually is meaning multiplication by this 1.
Because we have to divide both. I mean, we have to multiply both by 2 to get rid of the 3.
Yeah. That will. But the feel good, I'm saying the anticipation, like how to feel this. Do you get that? So this itself will say this is actually answer is a 6. But as you said, 3 by mathematically we can handle it. I don't like this 2. So balance it on the numerator denominator. This goes 1 to 1. So this will be a 6. But I am saying, you see the anticipation itself, 3 divided by, this is a 1 bigger than 1, big quantity, and this is lower than 1. So the answer we expect should be more than the numerator value.
Yes.
Okay. So when we see all of this, all we are dealing, all this thing is simply, can we do A plus B? Can we do A minus B? Can we do A over B? Can we do A multiplied by B? Okay, these are all the things what we learn. But
yes,
the beauty is, A could be one example could be, A could be simply a whole number and B could be simply a whole number. Then we know how to do this job very easily, all of them.
yes,
Because both of them are of the whole number type. Do you get that?
yes,
The reference is 0, and unit is 1.
yes,
The second example is, let's say both of them are fractions. So let's say A is 1 over 4 and B is 3 over 4. Here also reference is 0. Well and good. But the unit quantity what we are dealing is 1/4. Do you see that?
yes,
Then we can straight away do all of them. No problem with that, as long as the unit is the same. Third example, A is 1 over 4 and B is 2 over 3. Here also reference is 0, no problem, but unit is a problem, because this number belongs to a unit of 1/4, this number belongs to a unit of 1/3.
1/3, yes,
Okay, then we need to find a common unit.
1/12.
That is what helping us to do the job, right?
Yes.
So
Yes.
common unit is 1/12. Where we come across what is the need for that, then only these two things can be done. Either you do this and do the common unit and then do the division and multiplication, or we know that straight away 1/4 can be multiplied with 2/3, or 1/4 can be divided by 2/3 also. Straight away we can do. We don't need the common unit, and we know the reason for that. Do you get that?
Yes.
So that's what it is. We need to understand that. And also there could be a fourth possibility. I mean, the time being, I'm not going any other kind of number. It may come with a unit. The A could be like 1/4 of a meter, and B could be a 2/3 of a centimeter.
Then we have to convert meter to.
Let's make it even look like they belong to the numerical quantity wise. The unit is same. This is a unit of 1/4. This is also unit of a 1/4, right?
Yes. But the unit
But that is not enough. Yeah, this unit is actually making is bit of a work to get these two jobs done.
Yes.
But these two job also bit of a trouble. What happens? This multiplication of A and B, A is also a length, B is also a length. It will go to an area. But to get it as an area, we need to represent that. Area also can be represented as meter followed by a centimeter is 100% correct. But we won't write it like that. We either write it as a meter square or centimeter. This is the convention. Do you get that?
Yes.
There is nothing wrong with this. Meter multiplied with a centimeter, nothing wrong with that. Okay, for example, I'm saying if somebody says this is a length of 0.2 meter and this is a length of 10 centimeter, right? Okay, so now we can simply say find the area. Then we say that this is our length and this is our breadth. For example, we say area is actually length multiplied by breadth, right?
Yes.
So that is 0.2 meter multiply with our breadth is 10 centimeter. Well and good. We are asking multiplication, right? As long as the units are multiplied, these numbers are multiplied. So this will be it will be a 2, because 0.2 multiplied by 10 meter, a gap centimeter is perfectly correct.
Okay.
There is nothing wrong with that. But this will come with an unit of area. like a meter centimeter.
Yeah, but that is not the normal way how we.
Yeah, not a convention. The people will look at it. What is this? Even people can't understand this. But we need to understand this is perfectly correct. But we have, if you are given a meter multiplied with a centimeter, feel good is better I convert this centimeter to a meter. Then this is a meter. Centimeter is actually 1/100th of a meter.
Meter, yes.
So this is converted. So this is actually meter centimeter. If you write 2 units like a variable a b, if you write, that means it is actually a multiplied by b. Same with meter,
yes,
centimeter. That is actually multiplication. There is a multiplication going on here in between. And centimeter is actually equal to, we don't normally write the 1 in front of it because both of them got a 1 in front of that. Do you see that?
yes, yes.
So this 1 centimeter is only converted into a 1/100th of a meter. Then this become 1/100th of a meter squared. Okay, so that tells us this can be written as 2 multiplied by 1/100 meter squared.
Yes.
That will be 0.02 meter squared. Do you get that?
Yes.
Second possibility is the meter centimeter. We can say the meter can be written as 100 centimeter multiplied by 1 centimeter. So this will be 100 centimeter squared.
Right. Yes.
Okay, so same thing. So 2 meter centimeter can be written as 2 meter centimeter has become 100 centimeter. So multiplied by 100 centimeter squared. So that will be 200 centimeter squared. So this tells us 0.02 meter square is exactly equivalent to 200 centimeter square. And that is what this area is. I will get a small room here to tell that we can convert this also is equivalent to 0.1 meter, right?
Yes.
So in that case, the A is 0.1 meter multiplied by 0.2 meter. This is actually 0.02 meter square.
Yes.
This we got it here also, the same,
Yes.
maybe in a bit of a lengthy way. Also, we can say that this is actually 20 centimeter. So in that case, we can say that 10 centimeter multiplied by 20 centimeter. You see that?
Yes.
That is 200 centimeters. That is also we got it here.
Yes.
So in either way, all of them should be immediately click in our mind. Okay. Okay.
Yes.
So mathematics and how we are going to use it is all about the generic understanding and all possible ways of understanding. Like I put a plus b and all those stuff. A given quantity, like let's say a, this could be always coming with multiplied with some other quantity, and it can have a, because a is actually multiplied with a 1, a power 1 divided by 1 and added with a, this is what a single quantity is. A is equivalent to 1 multiplied by a divided by 1 power 1 plus 0. Right?
Yes. Yes.
This can be this one which is hidden in the a, and this one is hidden in the a, this one is hidden in the a, and this added with 0 is also hidden in the a. All of them can appear. That is what mathematics is. And when they appear, it will look like this is what the generic form: a multiplied by a divided by y power z add with a b. Right?
Yes. Yes.
This is we are trying to understand, and when we give a number value for that, the number can appear like a whole number, like a 9, or a fractional number like 2 by 9, or a 0.29. All those forms are also possible, and it can come with a direction like a -9 or -2 by 9 or -0.29. We should understand that also.
Yes. Yes.
Right? Number has its own family, and once we have this, Even this is a quantity, right?
Yes.
This x itself can appear in the form of x can also has its own 1 multiplied by x by 1 power 1 and addition 0.
Yes. Yes.
And this can also be generalized like this, right?
Yes.
Like
Yes.
you can get all these quantity can appear, and it may be non-ones here and non-zero here. Then that will appear here. Then how to know how to simplify or deal with all of this? What will happen? That is what the mathematics we are learning for our whole lifetime.
Okay.
Do you get that?
Yes.
So that is why addition, subtraction, continuity is repeated. Addition is multiplication, and addition and subtraction. Addition is opposite mathematical operation of subtraction.
Yes.
Okay. Multiplication is repeated. Yeah, but that is second point.
Yeah.
The multiplication is repeated addition. That we need to understand.
Yes.
Right? And then comes the division is the opposite operation of multiplication. Right?
Yes.
That tells us. Then comes, there is a repeated multiplication is the rise to the power of.
Yes.
So then comes the question, when we have this, then there has to be an opposite operation. Do you get that?
Yes. Yes, sir.
Let me complete that on today's session. Let's say we want to multiply x with itself. The center dot is multiplication, okay, in algebra. Okay, and it get repeatedly multiplied with x, and we have n number of times. N times it is repeatedly multiplied. Then this can be written very simply in mathematics. What quantity is getting repeatedly multiplied, that should be the base, and how many times it is repeatedly multiplied should be written as a smaller font. Yes. On the top right corner of this variable. Okay.
Yes, sir.
So once we know that, then comes the question. Okay, this x can be a fraction also, right?
Yes.
X itself can be a over b, and this whole power can be also a fraction, like x over y, for example. And this whole thing can be a plus or minus also. It can be a plus number or a minus number.
Yes, sir.
All these things you need to understand, and this can also come as a positive and a negative. Okay. So the final thing today is, let's say we write a is equal to x over b, x power b. Okay. We know what this is, right? X power b is what? X multiplied with x so many times with x itself, b times, right? This is an understanding, and that is equated to a. That is what this equation is saying. That's all. Full understanding. This is an equation. In the equation, left hand side is simply a variable named a, and the right hand side is actually rise to the power of, that is actually x rise to the power of b. That meaning x is repeatedly multiplied with itself b number of times. Once we have all this understanding, can we rewrite this in the other two forms, like what is x equal to and what is b equal to? Because this is a straightforward question, right?
Yes.
Because if x can be expressed as a can be expressed in terms of x and b like this. So from here we should know how to express the x equal to. So first of all, like if you ask this question and this question, simple job is look into what is given to us and can we have a good understanding? Yes. Look for what we are looking for. We are looking for x. Look at what is given. Something is given. Where is our x? We are interested in. It is on the right hand side. First job is swap this. From this swap this, right, to get the x. Swap. Okay. So that gives x power b is equal to A. Are you with me?
Yes, sir.
We want only X, right?
Yes.
What is the power of the X here?
B.
No, here we are
Here
asking. Yeah, okay, we are given with something. In there the X power is B, but what we are looking for is only X power 1, right? All we don't want is this power B. If you can mathematically correctly get rid of this power B as a 1, we are done. Isn't it?
Yes.
So how to make a quantity B to become a 1? Divide by B will become a 1, right?
Yes.
So X power B over B. That is what we are doing, because B over B is a 1. We have done an extra job on the left hand side, dividing the power by B. Do you see that?
Yes.
The right hand side, what is the power of the A?
A is
Previously.
1.
Yeah, 1. That 1 should also be divided by B to keep the
1.
balance.
Yes.
Do you get that?
Yes.
So this goes 1 to 1. That gets us our answer as a X power 1 is a X. This side, this is a bth root of A. Because we know that A power 3 is A multiplied with A multiplied by A 3 times. Do you get that?
Yes.
Now we are asking A power of, for example. That means A power 2 we know, that is A multiplied by A. But we are asking only, can you multiply, because A power 1 is itself a A. This is already A is there, full amount of A. That is what this 1 is saying. But we want only half of that. Do you get that?
Yes, sir.
So this has to be simply our, if you know a quantity, and if you multiply, if you find this quantity, actually this quantity can be arrived at A power 1, that power is divided by 2. So this is actually written as square root of A.
Yes. Yes, sir.
Okay. So this A power, yeah, bth root of
Bth root
A.
of A.
Do you see that?
Yes, sir.
So this is actually saying if the A can be split into B number of, like, divide that, take a B, take a A, divide by B. And you divide, divide by A, B number of times you have to divide. Do you get that?
Yes, sir.
Then after dividing B times, take only 1 out of that, that is what is bth root of A.
Yes.
Okay. How about the
Yes.
B? So in this side B. So here also same thing. First of all, write X power B equal to A, because B is in the right hand side, right? Swap it.
Yes.
Okay, now B is in the power. Do you get that?
Yes.
What to be done? How to bring it? It is in the rise to the power of. We want the B to be the base. We want it in the base level.
Okay.
Big question mark, right?
Yes.
I will leave it here. Think about it. We will discuss that on Sunday. Okay.
Okay.
Okay. Take care then.
Okay. Thank you so
Okay.
much.
Bye.
Uncle. Bye.
Yeah. Bye.